Okay, so now let me tell you a story now. Before discussing what is OSI and all, let me tell you a story. Okay, some time back, maybe by late 1970s or by that time. Okay, suppose I run a company. Okay, I run a company and this company is called, say, suppose ABC company. Okay, now I purchase some computers from XYZ company, which is the computer manufacturer. It's a computer manufacturer. Okay, now let me tell you, so these XYZ computers, say they have their own R&D department, and they will say, or they will research and they'll come up with certain rules and regulations for their computer. Okay, which is called, or which are called protocols. Okay, so their own set of protocols. Clear? Now I purchase, suppose, so okay, so guys, if at all you are not hearing my voice or anything, just let me know. Okay, now so here, so you got, so the XYZ computers will be working based on their set of protocols. Now let me tell you, so so I bought 100 computers from XYZ manufacturer. Okay, and I've interconnected all the 100 computers and they are perfectly working fine. Okay, so perfectly working fine means if I send something from this first machine to the second machine, I'm able to receive it, right? And the first machine and the second machine, they are processing it in the same manner. That means if I send a hello, then this message will be processed in the same manner by the second machine also. Clear? Okay, so whatever that I send is received and processed it easily. Now after some years, I purchased, suppose, PQR computer. I purchased some PQR or computers from some PQR computer manufacturer. The problem is that also then I started facing some issues, because PQR computer manufacturer have their own R&D department, which say come up with their own set of protocols, right? So the working, so the PQR computers working would be different from XYZ computers working. So when I interconnected the XYZ computer and the PQR computer, interconnected the XYZ and the PQR computer, what happened was, so when I send a hello message or something, if I send, then the PQR will not be able to process it. PQR will not be able to process it. So that is a problem, right? So I can connect XYZ computers, I can connect PQR computers together, but I cannot connect the XYZ and PQR together. Clear? That's where the problem started. So a lot of companies started facing the problem, and then an organization called ISO, International Organization for Standardization, this organization came up with certain, say, common rules and regulations. Okay, they came up with certain common rules and regulations called OSI model. Okay, just give me a minute. So guys, yes, so then ISO came up with something called OSI, and they asked all the companies to implement the OSI standard in all the computers, and all the computers started implementing that as well. All the computer manufacturers started implementing that as well. Then later what happened was, say, US Department of Defense, they came up with something called TCP/IP protocol or TCP/IP model, or it's called TCP/IP protocol suite or TCP/IP protocol stack. Okay, it was already there, but they updated it. They updated it and they came up with this one, and then by 1990s it was trending. Okay, it was trending in the sense all the computers manufacturers, they started drifting from this OSI to the TCP/IP model. So nowadays your computers or our computers work in this TCP/IP model. Then what ISO did was, say, this is the first standardized model, right? So what they did is they made this OSI as a reference model. They made this as a reference model. So you can refer it in case if you want to develop your own protocol, or in case if you want to say study about it, you can refer this OSI model, and that's why it's nowadays called OSI reference model. Clear? Okay, now this is what we are going to study, the OSI reference model. Okay, now let me tell you. So the working in the OSI, or so this OSI, I didn't tell you the full form, right? So OSI means Open System Interconnect. Open System Interconnect. Okay, now so the working of a computer is divided into 7 parts by this OSI. So OSI defines this working into 7 parts or 7 layers. That's what we call 7 layers. Let me tell you about the layers now. So the layer 1 is called physical layer. Okay, layer 2 is called data link layer. Layer 3 is the network layer. Layer 4 is the transport layer. Layer 5 the session layer. Layer 6 the presentation layer, and layer 7 is the application layer. Clear? So these are the layers. So if somebody asks you what is layer 1, so the answer to this is always, it is always physical layer. Okay, so layer 7 is always application layer. Getting it? So you need to study these layers. What are the names of the layers? So either you can study it in this order, layer 7 to layer 1, or you can study from layer 1 to layer 7. Yeah. Okay. Now let me tell you about, so here this application layer, presentation layer, and session layer. Yes, anybody? Okay, so this application layer, presentation layer, and session layer, these layers are called upper layers, and these 4 layers are called lower layers. We got upper layer, which are say layer 7, layer 6, and layer 5, and lower layers, which are layer 4, 3, 2, and 1. Okay, then yesterday somebody asked, right? Yesterday while discussing the hub and all, somebody asked hub works in physical layer. I told you that hub works in physical layer, right? And somebody asked what is the physical layer. So physical layer is the layer 1 in the OSI. So hub works in this physical layer. Okay, now say the switch, our switch works in data link layer, or it works in layer 2, and router, it works in layer 3, network layer, right? And at network layer you got an addressing scheme which is called IP address, and that's why it is called layer 3 address. Clear? Now in layer 2 you have an addressing mechanism called MAC address, right? MAC address is the addressing mechanism in layer 2. Clear? So now are you okay with what is, if I tell you it's layer 3 address, that means it is IP address and it is coming in network layer. I suppose you understood, right? Okay, now let me go to a diagram now. So this is the diagram. Okay, now let me just tell you about the diagram here. Okay, so now suppose machine 1 wants to communicate to machine 2, or machine 1 wants to send something to machine 2. If machine 1 wants to send something to machine 2, source, who is the source? Machine 1 is the source. Source is machine 1. And what is the destination? Machine 2 is the destination. Okay, if say this machine wants to send something to the second machine, then suppose some hello message or some hi message is to be sent from this machine 1 to machine 2. Then what happens is that, say this hi message is first passed to the application layer. It is first passed to the application layer. Then the application layer will process this data, or will process this, say this message, by adding some values. So whatever you add here is called the header. It's called the header. It consists of application layer related parameters. Clear? Getting it? Now, then this structure is now sent to the presentation layer, the second layer, which is presentation layer. Now the presentation layer will process it. That means to that structure which has been received from the application layer, it will add another value, or it will add another header. It will add the presentation layer header. Getting it? Okay. Then we'll add the session layer. Getting it, guys? So it is as if, say, suppose, just let me tell you. So as if, say, I've given you a paper. Okay, I've given you some messages, some paper. Okay, and I've given it to you guys. So how many guys we have? 1, 2, 3, 4, 5, 6, 7. 7 guys we have in different class. Right. So each of you guys will add your signature. Right. So Kevin will say sign, and say here again Vijesh. No, Vijesh is this. So Vijesh will sign, and your name again I forgot. Ritik. Okay, you doesn't look like Ritik. Okay. Okay. So now Ritik will sign. Now, so again Lakshit. So Lakshit will sign. Yes, Srikanth. Srikanth will sign. Naresh. Okay, or to remember your names. Nishant I remember, but I suppose he joined online, right? Okay. Yes. Okay. So like that, you guys will add your signature here, or you guys will add certain values to it. Right. So this message is now, say, passed to each layer. So each layer will add their own information. Getting it? So what happens is that the application layer will add certain value called application header, and then pass to the presentation layer. Then the presentation layer will add the presentation header. Then it is passed to the session layer, where the session layer will add the session header. Then will pass to the transport layer, where transport layer will add transport header. Then we'll pass it to the network layer, and network layer will also add network header. Then to data link layer, where data link layer will add not only the header but another value called trailer. Getting it? Okay. Then via the physical layer, this message is sent. Via the physical layer means via the cables. Okay, via the cables. So the physical layer consists of the cables. So via the cables, the data is sent as bits. Clear? Okay, then it reaches the destination machine. Clear? Okay, so now, so destination machine receives the message from layer 1, will give it to layer 2, which is the data link layer. Okay, then the data link layer, what he will do is that he will process this header and trailer, which is added by the same data link layer at the source side. Clear? And then what he will do is that he will process it, he will read it, and he will remove it. So this is called same layer interaction. It's called same layer interaction. That means, say that this data link layer at the source side has added a header and a trailer, which is removed by the same data link layer at the destination, and that's why it's called same layer interaction. Okay, getting it? Now then it is passed to the network layer, where network layer will also, say, process it, will just read this one, and will say this, or say will remove the headers. Okay, then we'll pass it to a transport layer. Then the transport layer will read the header, then we'll remove the header, pass it to session layer. Session layer will read this and remove the header. The presentation layer will also do the same, and finally given to the application layer. Then application layer will also remove the header. Finally you got the message. Clear? So this is the process that happens when you send something from machine 1 to machine 2. Clear? Now you can see, I told you, so each layer will add the headers at the source side, right? So this process of adding the header, it is called data encapsulation. It's called data encapsulation. You might have studied it in class, say lower classes, where, say, they will just give you the definition. Even I didn't know what is data encapsulation. When I studied the, say, class 12 and all, say, I used to mug up the these things, the definitions. So at that time I didn't know what is data encapsulation. Okay, so data encapsulation means adding these headers at each layer. That is called data encapsulation, which is done at the source side. Now at the destination side, whatever is added is removed, and that's called data decapsulation. Data decapsulation. Clear? Okay. Now the next thing. So at all the places you can see, at the source side, so each layer will add the headers and will pass the information to the next layer. So they are interacting with each other, right? The application layer is sending something to the presentation layer. So they are interacting each other. So that is called adjacent layer interaction. Adjacent layer interaction. Clear? It happens at the destination side as well. Okay. Now you can see, say at each layer, say this is the structure. For data link layer, this is the structure. For network layer, this is the structure. For transport layer, this. So the structure of data keeps on varying, right? So structure is collectively called, or it is known with a term called PDU. It's known with a term called PDU. There, at last, getting it? Okay. So PDU, it's called protocol data unit. Protocol data unit. So the PDU, or the protocol data unit of, say, a layer 2 or the data link layer, is this one. Okay, this structure. And this structure is termed as frame. It is termed as frame. So when I tell the frame, you should get this structure into your mind. You should have this structure in your mind. So when we discuss the data link layer, I'll be talking about the frame. So you should have this structure in your mind. Now, so the PDU at the network layer, it is called packet. The PDU at the at the transport layer, it is called segment. And the PDU for the upper layers, it is collectively called data. Okay, so this is the PDU at each layer. And the PDU at the physical layer, it's called bit. So that's why we tell, say, while passing through or while sending something through the cable, we have 10 Mbps bandwidth, or we have 100 Mbps bandwidth. So 100 megabits per second, because the PDU at the physical layer is the bit. Clear? Any doubt? Okay. So this is a very important diagram, because throughout the networking career you will have to keep this in mind. Okay. Yes.
Sir.
Yes.
One confusion. In data link layer, is there only MAC is there, or any other?
So yeah, only MAC is there. Only MAC means, say, MAC, even let me tell you. So each data, in the data link layer itself, we got different protocols, of which one protocol is called Ethernet. So you guys, again, let me tell you one thing, guys. Say if somebody asks a doubt, okay, it's okay to listen. Okay, but say if at all you are feeling confused, then leave it. Okay, so that is, say, his own doubt, then I'll be referring to that doubt. Okay, so the data link layer has got many protocols. So each layer has got many protocols here. Okay, they have got many protocols. And in the data link layer, you got a protocol called Ethernet protocol, and in Ethernet, that addressing mechanism comes the MAC address. For some other protocols, it might be something else. Got it? Okay.
Removing the
headers.
Data headers and trailer is called what?
Data decapsulation. Okay, so let me just show it to you here. Decapsulation. It's not de-encapsulation. De-encapsulation is also it's also termed like de-encapsulation, but this is decapsulation is the exact word. Decapsulation. This is encapsulation. This is decapsulation. Okay. So now we have discussed what is PDU, the data encapsulation and decapsulation, the same layer communication, adjacent layer communication, upper layers and the lower layers. Clear? Okay, everyone? Yes. Now we'll briefly discuss about the upper layers. Okay. Now, talking about the upper layers. First we have the layer 7, which is application layer. So application layer, it provides user interface. It means application layer, say suppose if at all this is the user, and if at all so this is the computer, right? So whatever that you see, the user interfaces, it is provided by the application layer. So application layer, it provides, you can say it provides the user interface. Then say it provides application to services, or the reverse also, you can say it provides services to the application. That means if you take an application, example, if you take the web browser, suppose Google Chrome, suppose you are browsing, you want to browse the internet. So if you want to browse the internet, you will take the Google Chrome, right? Or if you want to say browse the internet, so browsing the internet, you will utilize one protocol called HTTP protocol. You might have heard of it. HTTP means hypertext transfer protocol. Hypertext transfer protocol. So hypertext transfer protocol, let me tell you what it is really. Okay, so when you are browsing something, suppose if you are browsing say Ferrari car pictures, so you have searched and you have gone to a website and you are downloading it. So what happens is that from your computer you are say downloading a file, or you went into a website, suppose www.ferrari.com or whatever be the website. So what happens is that say this website or this file, so this is actually saved in a machine called web server. It's actually saved in a machine called web server, which is present somewhere in the world. We really don't know where it is present. So what happens is that I will send, say from my computer, I will send to the server like this: hey server, get me this picture, get me the Ferrari picture. Okay, and what he will do is that he will search it and he will come up and he will say show it to you. Getting it, guys? So this is the HTTP process that happens. Okay, now so when you send something, and when it is available, then they will send a return code of 200 or something. Okay, so 200 or so some other values are also there. Now when if at all the file is not present, if at all they have deleted the file, that Ferrari file or that picture has been deleted, then you might have seen something called the error 404 not found, right? So that means you have searched something and the server is replying back, say I did not found anything, I did not find anything what you have searched, I did not find it. So that's the 404 not found error, which is the, say you might have heard of it, right? Yes or no? Okay, so this is the HTTP service. So now let me come back. So when I browse the internet, so this HTTP service is to be used, or when I use the Google Chrome, this HTTP services or is the HTTP service can be used. So that is defined in which layer? That's defined in the application layer. So that's why I told it provides application to services, or it provides service to application. Clear? Okay, now again just give me a moment. Now the next one is the presentation layer. So the presentation layer here, okay, so now let me tell you about the presentation layer. So presentation layer, say it presents the data to the application layer. How the data can be presented. So suppose that you are sending a picture, then the picture needs to be represented using which format? It is represented in the presentation layer. The best example I can tell you is, suppose you are sending, suppose the computer, one computer is sending some text messages. Hello, how are you? Hello, how are you? Okay, so this computer is sending some text messages to the next computer. So if he is sending the text messages, then say this text messages can be represented using two methods called ASCII. Okay, the first is called ASCII. You might have heard of it. Okay, ASCII code. ASCII means American Standard Code for Information Interchange. Suppose, say I don't remember the exact values. So here, if you represent A, B, C, if your message is something A, B, C, D, E, F, something like that, then A is represented using some certain numbers. Say something like 32, 31, some numbers. Okay, B is represented using another number, 33, 34, like that. Then C is represented using another number, some 34, like that. So these characters are represented using ASCII code. Clear, guys? Now suppose sometimes it can be represented using some EBCD code as well, extended binary coded decimal interchange code. So how this needs to be represented, that is, or presented, that is mentioned in the presentation layer. Getting it, guys? Okay, yes. Am I fast? Okay, now then the third one is the session layer. Okay, third, it's not really the third one, layer 7, layer 6 and layer 5. So session layer. So now let me tell you about the session layer. The session layer, it creates, it maintains and it terminates the sessions. Sessions means the time interval. When you want to send a data, the time interval, so they will create a time interval. Within this time interval, you have to send this data from the source to the destination. So the time interval, creating the time interval, maintaining it, terminating it, everything will be taken care by the session layer. Okay, now again they got one more function called dialog management. Dialog management means, suppose if I'm sending something, suppose I'm sending a file, say this file may need 3 milliseconds to send from the source to the destination. Now I'm sending the same file, suppose. Okay, so this time so previously it was full duplex communication. Now it is, suppose, half duplex communication. For half duplex it may take 6 milliseconds. To send the data it may take 6 milliseconds. So based on the transmission modes, which are simplex, half duplex and full duplex. Right, I have taught you that. Simplex, half duplex and full duplex, which are the transmission modes. So based on the transmission modes, we can say allot the sessions, or we can allot, or we can say give them the sessions. Okay, that's called dialog management. Clear? Yes or no?
Yes.
I need response from you guys. Yes or no?
Yes, sir.
Okay, now so these are the upper layers. Now coming to the lower layers. So now again one more thing here, upper layers. Okay, so here you can see the top 3 layers define how the application within the end station will communicate and with each other and with the users. Okay, so these upper layers here, what happens is that if you are sending something, so these upper layers, whatever the value is there in these upper layers, it is applicable to the end devices probably. Okay, it is not for the end devices. In between devices will also take care of this, but for now just understand, say only the end devices for just now. Okay, now regarding the lower layers. The lower layers here, you got L4, L3, L2 and L1, which are the transport layer, network layer, data link layer and physical layer. Okay, transport layer is responsible for transporting the data. It is responsible for transporting the data. Okay, so for transporting the data, in the transport layer uses, or the transport layer consists of 2 main protocols which are called TCP and UDP. Okay, TCP and UDP. So TCP means transmission control protocol. Okay, and UDP means user datagram protocol. Okay, TCP is transmission control protocol and UDP is user datagram protocol. Okay, now TCP provides reliable communication. TCP provides reliable communication. Reliable means, suppose, say I'm teaching you something, right? Or let me tell you, say you are sending some WhatsApp messages. Say then you will receive back, say the double tick or you will receive back the blue double tick, right? So that is a kind of acknowledgement. Acknowledgement means you have the confirmation it is received there, or it has been delivered to the person, or it has been read by that person. So that is a kind of, say, reliable service. You can rely it. Okay, so reliability is based on the acknowledgements. You are receiving back certain confirmation. The confirmation is the acknowledgement. So when you are sending some registered letter, then you will receive back the acknowledgements. Right, it has been received. The person who has received it, say it has been received, he will sign it and give you. Right, so it has been received. Clear, guys? So that is the reliable delivery. Okay, so reliable communication. Now, so TCP is responsible for the reliable communication, and UDP here, say, is used for unreliable delivery. Okay, so if at all, just let me tell you. Okay, so now that I am, say, just calling him, say suppose Ritik, I am calling Ritik, hey Ritik. Okay, then everyone is hearing it, right? But none of them except Ritik will have to reply back, right? So only Ritik will reply back. Nobody will reply back, or say you guys won't reply back. Getting it, guys? So, or let me again tell you, suppose, technically speaking, say, suppose you're watching a YouTube video, suppose a live YouTube video. Okay, if you're using a live YouTube video, then say whatever that, say the computer is, or say suppose this is the YouTube server or whatever. Okay, so whatever that you view it from them, say they are continuously sending it. Okay, I don't need, or my computer will not send back a confirmation that I have received it. There is no need, because say here for unreliable delivery or for the YouTube live or something, the live things and all, you need to say receive it as soon as possible. So there we really don't need the confirmation. Getting it, guys? We really don't need the confirmation, because say whatever data needs to be sent is to be sent as soon as possible. So whereas, so the reliable communication will be, say if at all you didn't receive it back, they will send it back. Getting it, guys? Okay, so that is the difference between reliable and the unreliable delivery or the unreliable communication. Okay, now so the transport layer performs error recovery procedure, which I'll tell you a little bit later. Okay, now it provides the end-to-end communication. It provides the end-to-end communication. That means if at all I'm sending a data from, say, the computer which is in India to a computer which is in US. Okay, then say it provides end-to-end communication or the connection, because, or it means we will create a connection between the computer in India and the computer in US. A logical connection is found between the computer in India and the computer in US, even though you got different or multiple devices in between. Clear? Okay, you'll understand a little bit later. Okay, when I teach you this, what is this end-to-end connection and all, I'll teach you a little bit later. Okay, now we are just going through this, say briefly, okay, about the lower layers. Now the network layer provides logical addressing or IP addressing, right? Then the fragmentation, which I'll teach you later, and the routing. Okay, and the data link layer provides, so these are the data link layer, say functions, which you will study again later. Now coming to the physical layer, I told you the physical layer is all about the cables and the physical, say the devices, those things and all, right? So here, while say sending the data through the physical layer, say it is moved as bits between the devices, right? How many Mbps? So, and say it specifies the voltage, the wire speed, the pin out of the cables, etc. Okay, so that's the physical layer. Okay, now we can go, or this application layer and all, we have, say, discussed it. Okay, so now again, yeah, so now again coming to the application layer here. So the application layer we have already discussed, but again let me tell you. So I told you that the application layer consists of multiple protocols, or each layer consists of many protocols, right? So the application layer protocols, you can see HTTP is one of the protocol. I told you about the HTTP, hypertext transfer protocol. Now the next one is called DHCP, Dynamic Host Configuration Protocol. Right, I told you, I suppose. Right, say I told you, if at all you want to receive, say if at all you haven't or say I told you the computer needs an IP address for communication. Now the DHCP server or the DHCP service provides IP address to the computers or to the devices. If you haven't configured any IP address to the devices, you will get the IP address automatically from this DHCP service. Clear? So that is also an application layer protocol. Now FTP, file transfer protocol, I told you about that. Say file transfer protocol, suppose if you want to say copy a file from a server, you will use this FTP service. Okay, file transfer protocol service, you will copy it via this service. Okay, now you got DNS, domain name server. Okay, so which will translate this the domain name, which will translate to the respective IP address. Suppose the Google is having the IP address 1.2.3.4, then this translation will be done by the DNS. Okay, so let me just briefly tell you the DNS, the working of the DNS here. Suppose, where's paint? Let me just give me a moment. Okay. Suppose you are browsing www.google.com. www.google.com. If you are browsing this, say this needs to be translated to the IP address. Suppose the Google is having the IP 1.2.3.4. Then say what happens is that say this computer will have a local DNS in that machine itself. In that machine itself, it will have a local DNS or the resolver. Okay, so it will check whether that local DNS has got this translation or not. Okay, so www.google.com, whether the IP address, it knows about the IP address or not. If it doesn't know the IP address, then that will say ask the DNS server. Then that will ask the DNS server. Okay, so sometimes the DNS server will be the, say, you can say the modem that you have connected. The modem, or nowadays it's called Wi-Fi router or router. Okay, so what happens is that it will ask the router. Okay, so because the router can also act as a DNS server. Okay, so the router will also, they may also have say this table www.google.com and the IP is 1.2.3.4. If it is not there, then the router may ask, the router will be say configured with say something called root DNS. Something called root DNS. Okay, or suppose, okay, they will ask a larger DNS server. They'll ask a larger DNS server. Okay, so they will ask the larger DNS server, so which will say tell the router which is the DNS, which is the IP address. Then this router will send it back to the computer. Actually you got some more process here, but if I tell you now, you may not be able to understand. Okay, so now that I am skipping that one. Okay, so this is how, so again what happens is that this DNS server will have this entry www.google.com and the respective IP address is 1.2.3.4. it may have it. Okay, and say they will send it to the router and the router will send it to this computer, and the computer will come to know that the IP address for google.com is say 1.2.3.4. then they will start sending the data to 1.2.3.4, which is Google. Clear, everyone? Okay, now guys, again the next thing, SMTP. SMTP means simple mail transfer protocol. Simple mail transfer protocol. Okay, so it is used for sending the mails. That's it. Okay, you don't have to study in depth of the SMTP and all. Okay, now you got telnet one, telnet service. So telnet means say you are accessing the remote access or let me tell you what it is exactly. Suppose you got, are you guys feeling bored? Do you need a break? Oh, need a break?
Maybe 9 hours, 5 minutes.
No, sir.
No. At 9 o'clock? Okay, sure, I'll give a break at 9 o'clock. Okay. Now, so here, telnet. So telnet here, suppose I am in computer. Okay, say I have a computer, or say I am in front of the computer which is in India. Now I want to configure a router. Okay, configuring the router, we have not come to that portion yet, but suppose you want to configure a router. Okay, so you need to say type something, or you need to do something in a router which is present in US, United States. If you want to do something, say you can't take the, say suppose you can't take the flight and you can't go now, right? Again, so how many times you will go like that, right? So if at all you want to configure a router, it is not possible for us to each time, it's not possible for us to go there and configure the router and come back, right? So here you will utilize a service called telnet service. You will study that later, how to do the telnet service. I'll teach you. Okay, at that time you will understand it more. Clear? Okay, just say consider that this is a remote access. A remote access. Remote, that means, say if you have a TV, then if you have a remote, you can control the TV from anywhere, right? Say if at all you have a, say, TV in that classroom, and if at all I have, say, the remote in my hand, I can say increase the voice, decrease the voice, or I can say control it, right? From a remote location I can control it, right? Similarly, if I am in a remote location also, I can access these devices and I can configure these devices using a service called telnet service. Okay, yes, I suppose everyone is getting it, right? Okay. There, Srikanth. Okay, yeah,
Yes,
Kevin.
sir.
Yes. Yes. No.
Yes, we are getting.
Okay. Okay, you were telling that you got it. Okay, yes. Now the presentation layer also. So these things I've already told you guys. You can say when I give you the PowerPoint, you can take a look at it. Okay, these things I've already told you. And one more thing, guys, I forgot to tell you. So the presentation layer has two primary functions: conversion or the translation. Okay, how to translate or how to present the data. Now the second function is the encryption function. Encryption means, say, let me tell you. So suppose we have, say, let me again take an example here. Suppose we got Vijesh here. Okay, and we got who is it, say Ritik. Okay, Vijesh and Ritik. So suppose Vijesh is sitting here and Ritik is sitting here. Okay, now if Vijesh, so in between you got many people are there. Okay, suppose we got Kevin, we got suppose again Lakshit. Okay, Lakshit and Srikanth and Naresh. Okay, so even daily I may ask you names, but now again there Satish. So the problem is that when we have, say, friends, right, Satish, below we have a Satish. Okay, when you tell Satish, I'll automatically have his face in my mind. That's the problem. So now, so in between we have many people. Now Vijesh want to send something to Ritik. So he can send the message to Kevin, and Kevin will pass it to Lakshit, and Lakshit will pass it to Srikanth will pass it to, say, Naresh will pass it to Satish, and Satish will pass it to Ritik. But Vijesh doesn't, or say while passing it to Kevin and everyone, what happens is that they are also able to read this data, right? So what you need to do, or what Vijesh will do, is that suppose Vijesh is telling, say, can I have a cup of tea, or can we go for a tea? Okay, like that Vijesh want to tell Ritik. Okay, so if Kevin reads it, Kevin will also come, right? Now if Lakshit reads it, Lakshit will also come. Now Srikanth reads, so everyone if reads it, they will also come. So they want to go, so without letting everyone know about it. Right. So what Vijesh will do is that Vijesh will say, can we go for T? He will convert it. So can we go for T? Okay, he will convert it to some other say values. Okay, suppose hash 8 4 3 2 1 ABC 2 3 4. This value is converted to unreadable format. That is called encryption. Okay, you have something called hash also. Okay, that's what you told, right? Okay, no.
I thought encapsulation.
Not encapsulation, not encapsulation. No. It is encryption. Okay, encapsulation is different, encryption is different. Encryption means you are encrypting the data. That means you are converting it into some unreadable format using a key and all. Okay, so you will encrypt the data. So when Kevin receives it, Kevin is asked to send it to say Lekshit, or Kevin is asked to send it to Ritik. Okay, so when he opens it, he will not understand it. He will not understand what is the message. He will not understand. So then it will be passed to Lekshit. Lekshit will also not understand. The same with the Srikant, same with Naresh, same with Satish. And Satish will pass it to Ritik. And Ritik will de-encrypt it or decrypt it. Will decrypt the message. Okay, so he will decrypt the message and say he will convert it back to the same old message. Can we go for T? And he will say, okay, understand this. So this is the process of Sleepy. Okay, encryption. And encryption is done in the presentation layer. It's done in the presentation layer. Okay, now again, so this is the one more function of presentation layer. And one more function is that, say, it provides compression. Okay, compression. When you want to compress the data, the compression is done in the presentation layer. Clear, guys? Okay, now the session layer, I've already told you about the session layer. Okay, you can read it. See, providing the dialog control between the devices, creating and maintaining the dialog. Dialog means the sessions, that's it. Okay, and say the dialog management. Okay, and initiate the dialog, keep them active, restart. So again, say if at all you might have noticed, if at all you go into the say the bank websites, right, the bank website, or if at all you're doing some online transactions, some sessions will be created, and after some specific time they'll mention that the session timeout is there or session has expired, right? So creating the session, maintaining, and those things, everything is actually the function of the session layer. Okay, now the transport layer. Okay, so transport layer, so I told you the two protocols at the transport layer, it is TCP and UDP. Okay, now transport layer segments and reassembles the data. Let me tell you. So here, when it comes to the transport layer, okay, now yes, so when it comes to the transport layer, at the transport layer, suppose you want to send, or you have a computer, you have another computer, you want to send a 1 GB file. You want to send a 1 GB file from this computer to this, from the first computer to the second computer. Okay, it is not the entire file, I mean it is not sent as a single file. This file is not sent as a single file, but this file is now cut into smaller pieces. Or at the transport layer, we will cut this into smaller segments. We'll cut it into smaller segments, and this process of cutting it into smaller segments is called segmentation. It's called segmentation. Okay, suppose that I'm having a data. Okay, suppose this is the data. This data consists of, suppose, 4000 bytes in size. This data has 4000 bytes in size. Okay, suppose this is 4000 bytes in size. Okay, what happens is that even before sending this file, so this file is now divided into smaller pieces. Okay, so what happens is that, say if they want to send certain data, and suppose they want to send the reliable delivery, they want to send the reliable delivery. If it is the reliable delivery, then these computers will use the TCP protocol. These computers will use the TCP protocol. Now, so for sending the data using TCP, you are not really sending the data. Okay, at first, I mean, you are really sending the data, but not really sending the data at first. Okay, so if at all, suppose Vijay is calling me. Okay, even Vijay is pinging me in the WhatsApp or something. Okay, so suppose he has a doubt. Sir, what is TCP or what is UDP or what is network layer or what is transport layer? So before even telling the doubt, he will introduce himself. Right, sir, this is Vijay. So are you free now? Right, say then he will ask, I have a doubt. Right, so if at all I say that I am free, then he'll tell I have a doubt and he'll ask the doubt. So then what happens is that at first they will establish the connection between them. They will establish the connection. If it's the TCP that you are using, they will establish the connection. So then after, say, Vijay has told me that this is Vijay, so are you Bharat sir? Then this is Vijay. Are you free? Now I have a doubt, can I clarify? Then the connection is established between myself and Vijay. Clear? Then only he will send the data. Clear, guys? So the connection is established first. Okay, so now let me tell you about the connection establishment. So suppose if this is the computer and this is the second computer, this is the first computer or the source, and this is the destination. Okay, what the source will do is that he will send a segment. And this segment will have us, say, he will send a segment. Okay, he'll send a segment set with a bit value. There is a bit value called SYN bit. He will set the SYN bit, informing that, say he'll set the SYN bit, informing that, or the destination, when he receives this SYN bit, he will come to know that the source needs to establish the connection. Okay, then if the destination is free and if the destination is ready to establish the connection, he will also send back a segment. And this segment will consist of the SYN bit. The SYN bit will be there. That means he is, say, ready to establish the connection. And along with that, he will set an acknowledgement bit also. He will set an acknowledgement. Whatever that you have sent, I have received it. I am acknowledging that. Okay, plus this SYN. This SYN means I am also ready to establish the connection. Clear? Then the source, what he will do is that he will send back the segment set with acknowledgement. Clear? Okay, I have also received back your confirmation. Let us start sending the data. Clear? This process is called connection establishment. Clear? Okay, now the connection is established. Now they will send the data. Clear? Now to send the data, again, suppose you want to send the data, suppose the data is 4000 bytes in size. Okay, guys, we'll give you a break. Okay, I can see some guys yawning, I can see some, say, guys, eyes are going down. Right, I'll give some break and then we'll continue. Okay, then we'll start with sending the data. Okay, yes or no? Okay, yes. So how many minutes you need? 10 minutes. Okay, we'll give you, okay, say suppose get back at 9:10. Okay, I usually give 5 minutes only, but as you asked for 10 minutes, I'll give you up to 10. Okay, yes guys, make it faster. Okay, so guys, suppose now that they have established the connection, right? So I told you that they will establish the connection using, so this method is called three-way handshake method. So they will use the three-way handshake method. Sometimes it can be four-way also. So it is three-way handshake method. Now, so they'll establish the connection using three-way handshake method. Then what happens is that then they will send the data. Okay, so to send the data, I told you they will split this data into smaller pieces, right? So each piece is called a segment. Okay, now to represent the segment, so this is segment 1, this is segment 2, this is segment 3, and this is segment 4. To represent the segment, so I can represent it using segment 1, 2, 3, and 4, but the segments are represented using a number called sequence number. It is represented by using a number called sequence number. Okay, so now suppose that I have split it into 4 parts. Each part consists of 1000 bytes. Here 1000 bytes, here 1000 bytes, or let me write it here. Okay, so here 1000 bytes, 1000 bytes, 1000 bytes, and 1000 bytes. So everywhere it is 1000 bytes here. Okay, now what happens is that, say suppose this consists of, say, from the first byte to the 1000th byte. Okay, or suppose let me draw the ending here. This consists of the 1000th byte. Now this starts, the second, say, the second segment starts from 1001 byte to 2000 bytes. Clear? Now the third one starts at, say, 2001 byte to 3000 byte. Okay, the fourth one starts from 3000 first byte to 4000 bytes. Clear, guys? So the first one, okay, so it's the first segment, it starts from the first byte to 1000 bytes. And the second one starts from, the second segment starts from 1001st byte to 2000 byte. Then the third one starts from, say, 2001st byte to 3000 bytes. And the fourth one starts from 3001st byte to 4000th byte. Clear? So now to represent the first segment, we will use the sequence number 1000. We'll use the sequence number 1000. So this segment is represented using sequence number 1000 because it consists up to the 1000th byte information. Clear? Now this, what about this one, the second segment, say it is represented using sequence number 2000. That means it consists of up to 2000th byte information. Now this will be represented using the sequence number 3000. It means it consists of 3000th byte of information. Now the fourth one, it consists of, or it is represented using sequence number 4000. It means it consists of 4000th byte of information. Clear, guys? So this is how they will do the segmentation. Okay, now segmentation is done, say, as per the source and the destination's capability. Segmentation is done based on the source and the destination's capability. Okay, so what happens is that while going for the three-way handshake or while establishing the connection, they will share certain values with them. Okay, so the source will share certain values with the destination and the destination will also share some values with the source, and they will decide, say, how to segment it. Sometimes they will segment with 1000 bytes. Sometimes they will segment with 2000 bytes. Sometimes they will segment with 500 bytes, like that. Clear? Okay, now after segmenting or after segmentation, then they are going to send the data. So now shall we send the data? Okay, so now sending the data itself consists of two methods. Okay, so now just give me a minute. Okay, yes. So sending the data itself consists of two methods. The first is called forward acknowledgement process. Forward acknowledgement process. And the second is called delayed acknowledgement process. Forward acknowledgement process and delayed acknowledgement process. Forward acknowledgement means, suppose you are sending, suppose this is the source and this is the destination. Now the source, what he will do is that he will send the sequence number 1000. That means the first segment. Then the destination will acknowledge back. Acknowledgement number 1001. So 1001 means he has received up to 1000 bytes. He is expecting from 1001 onwards. Clear? Okay, then what he will do is that the source will now send the second segment, that is from 1001 to 2000, the sequence number 2000. Then he will acknowledge back. Acknowledgement number, so he received up to 2000, expecting from 2001 onwards. Clear? Then he will send back the third one, which is sequence number 3000. Okay, now he will acknowledge back, say sequence number acknowledgement number say 3001. It means received up to 3000, expecting from 3001 onwards. So this is the forward acknowledgement process, and in the forward acknowledgement process, the segments, each segment is sent, then only after receiving the acknowledgement they will send it back. Clear? Any doubts in this one? Okay, now the next one is called delayed acknowledgement process. Delayed means, say suppose you will be sending a group of segments. You will be sending a group of segments. So here sequence number 1000 is sent, sequence number 2000 is sent, sequence number 3000 is sent. Then you will receive back an acknowledgement, say received up to 3000, expecting from 3001 onwards. Clear? Okay, then again say they will send it. Okay, sequence number 4000, sequence number 5000, sequence number 6000. Then again they'll send back an acknowledgement number 6001. Clear? So this is the delayed acknowledgement process. A group of say segments are sent, and for the group of segments, say the source will receive back an acknowledgement. Clear? Now there is a problem. So here the delayed acknowledgement itself, you got different types. Let me tell you about it. The first is called buffering. It's called buffering. So buffering means you are continuously sending the data. You are continuously sending the data. So there is a problem with buffering. The problem is that you will have, say suppose, what if I'm continuously teaching you for 10 hours? What if I'm continuously teaching you for 10 hours? What happens? You will be exhausted, right? Say the very thing will happen to this here also. The field exhaustion means, say suppose you will reach your saturation level, right? Say after delivering something, say, or after receiving, so after studying something, say you will feel saturated. You will feel saturated means in your brain you will not have any more space to accommodate the further things, right? So you will be in another world, right? So once say this or your brain gets saturated, then you will have to take a break. You will have to take a break, right? So the same thing means if you're continuously sending something from the source to the destination, so the destination here, it receives these messages, right? And it has a memory called buffer. It has a memory called buffer, and the buffer will get full here. The buffer will get full, or the saturation point will come here, right? So at that time, if at all the computer is low here, the buffer remains full, and whatever that you send here cannot be accommodated here, right? So whatever that you send will be a waste, and this process is called buffer overflow. So the buffer overflow happens. Clear? So to avoid the buffer overflow, say they have come up with a process called windowing. They have come up with a process called windowing. So windowing here, it means suppose you are sending the data. Suppose this is the source machine. This is the source machine, and this is the destination machine. Okay, so the source is sending some data here, or some segments here. Okay, so sequence number 1000. Okay, now sequence number 2000 and sequence number 3000. When they send it, so here when they are sending it, suppose when they have sent the sequence number 3 segments itself, the buffer got full. If the buffer got full, so or if you get saturated, what will you say, guys? What will you say? sir, say whatever that you are teaching, say it is I can't accommodate in my mind, say my mind or my brain is full now, give me some break. Right, the same thing will be told by this computer itself, I mean this destination itself, but instead they'll use the technical things. So they will send back something like this: acknowledgement number 3001. He's acknowledging 3000. I've received up to 3000, expecting from 3001 onwards, but my window is equal to 0. My window is equal to 0. Window here means, say the free space here is 0. I do not have any free space in my, say, buffer. My free space is 0. He'll update. So the source will understand, okay, he has received up to 3000, expecting from 3001 onwards, but I should not send it now because the window is 0. Clear? So now what happens is that, say the source will wait some time, and by that time the destination will process this information, and by that time he will have from some free space in the buffer. Then he will reply back like this: acknowledgement number 3001. Okay, received up to 3000, waiting from 3001 onwards, and my window is equal to whatever be the window, he will send it. Suppose, say 4000, or suppose 5000. Okay, that means 5000 bytes are free in his buffer. Then what the source will do is that the source will send 5 more segments here. He'll send 5 more segments because each segment the size is 1000 bytes. So 5000 bytes means he can send 5000, say 5 segments here. Clear? And the number of segments which are sent is called, so now I've sent 1 2 3 4 5. So the number of segments here sent is the window size. It is the window size. So they will update the window or the window size, and thereby they will now, suppose that after sending 5 segments, he'll update it like this: acknowledgement number, say suppose this is sequence number, suppose 3000, right? So this is 4000, 5000, 6000, 7000, 8000. So the acknowledgement number 8001, and my window is equal to 3000. That means now that I cannot accommodate, say 5 segments, now that I can accommodate only 3 segments here. Clear? So what happens is that now this source will send the 3 segments here. So he will keep on updating the window. Clear? So this is the windowing process. Clear, guys? Okay. So this is the windowing process. Okay. So this is another method for, say, delayed acknowledgement process. Okay. And again, guys, make sure that, say, this is for TCP only. We are discussing about TCP, the reliable communication. We are not discussing about the UDP. Okay. Now suppose you are sending the data and you have sent all the data now. You have sent all the data. When you have sent all the data, then at last you have to terminate the connection. You have to terminate the connection. That process called connection termination. Okay. Suppose Vijay has asked me the doubt. Coming back to the old example, Vijay has asked me the doubt, and the doubt, he has told the doubt, and the doubt I've answered it, I've clarified his doubt and all. Then afterwards what he'll tell: okay sir, my doubt is clarified, I'll hang up the phone. He'll cut the phone. So there is a connection termination process also, right? So the connection termination process, say suppose this is the source machine and this is the destination machine. What happens is that the source will send a segment, okay, and this segment will have another bit set that is called fin bit. That's called fin bit. He will set a bit called fin bit. So the destination will receive it and will acknowledge it. I have acknowledged. Okay, but if the destination has got some values, so suppose he might not process this bit. Okay, so it will take some time for the destination to process because he might have, say, many things in his buffer. Say later when he processes it, he will send back another segment set with the fin bit. Clear, guys? So he will send back another segment set with the fin bit. Clear? Now, so the source will understand, okay, so here this portion or this time it is called half close condition. Half close, because whatever source has to do, source has completed it. Now the destination has to perform these things, and mean destination has to perform all or need to process everything, and the destination has to close it. Clear? So the destination, now the destination is also ready to close, and then the source will send back an acknowledgement. Clear? So this time this condition is called full close condition. It's called full close condition. Now what happens is that, so previously for the connection establishment, after the three-way handshake, say what happens is that a virtual connection is established. A virtual connection is established. Now this virtual connection will get terminated. They will break the virtual connection, or they will break the virtual circuit. So this is the connection termination process, and this process called four-way handshake. It's called four-way handshake because four messages are sent. This is the first message. The source is sending the fin bit, and destination will acknowledge it. That's the second message. Now the destination will send it back, the fin bit. It will send it back. Then the source will also acknowledge. So that's the fourth message. So that's called the four-way handshake process. Clear? So this is how the TCP will send the data. Okay, so now let me tell you, let me take the PowerPoint here. Where is it? Yes. Suppose, okay, so I told you in the transport layer you got two protocols, connect TCP and UDP. Okay, now TCP is a connection oriented protocol. I didn't tell you what is connection oriented protocol, but I have explained it. Let me tell you what it is. TCP is connection oriented protocol means, say you have to create the connection before sending the data. Right, there are certain mechanisms before sending the data. There are certain mechanisms called connection establishment and connection. Say after the sending the data, they got a connection termination process, and that's why it's called connection oriented protocol. Clear? So now they will, or you will establish the connection using three-way handshake. Then they will use the connection either maybe say with the forward acknowledgement process or the delayed acknowledgement process. And the delayed acknowledgement process also we have studied two things, buffering and windowing. And then after sending the data, you will terminate the connection termination. Clear? So this is the process that happens in TCP. Now suppose UDP. Okay, if you are going with UDP, then that is connectionless protocol. That means you really don't want any, say, connection establishment, connection termination, nothing like that. Suppose Vijay is calling his mom or dad, or his say his family member. Okay, then he doesn't have to ask hello. He doesn't have to introduce himself, right? Say hello, is this mom? Say I am Vijay. Are you free now? Is this necessary? No. So suppose he is going home today. So then he'll tell, I am coming home. He'll just, even when she pick up the call, when his mom pick up the call, he'll tell, I am coming home, and he'll say cut the call, right? Or so this is the connectionless protocol. That means without even sending, say, or without even going with the connection establishment process, they'll be directly sending the data. Clear? So they'll directly keep on sending the data, and even the acknowledgement is also not expected. Clear? So this is the UDP, which is connectionless protocol. Clear? Now the next thing. Okay, now guys, where is it, the PowerPoint? Now the difference between TCP and UDP. Okay, TCP has connection establishment, UDP. So whatever things are here, say in the TCP, it doesn't is not supported by the UDP. So connection establishment, flow control, congestion control, acknowledgement, error recovery, reliable delivery, everything is supported by the TCP. So no such things are supported by the UDP. Okay, and TCP, I told you TCP is used for transporting the data, right? So transporting which data? Transporting the HTTP data, or say suppose the TCP. So I told you transport layer is responsible for transporting the data, and TCP transports the HTTP, FTP, SMTP, Telnet, these data traffic. Okay, while the UDP uses or the for DNS, DHCP, RTP, VoIP, etc. for these connections or for these protocols, they will use UDP, because these DNS and DHCP, these things doesn't require, or they are unreliable protocol, or those are unreliable things. Okay, suppose let me tell you about RTP, real-time protocol. Suppose I'm sending the voice, or say suppose Zoom, I'm using the Zoom application. So if at all I use the Zoom application, say there the Zoom will use UDP. The Zoom will use UDP because it's an interactive session. Okay, whatever I send it, hey good morning, if I send it, say that should receive at that moment itself, right? So there say they are focusing on the speed, how much faster you can deliver it. Even say some time back, say they told that, say the online people told, say they can't hear my voice is breaking, right? So if my voice is breaking, say again let me tell you what happened there. If my voice is breaking, say the source, I am transmitting something, my computer is transmitting the UDP packets. Okay, and when they say they might have got lost in the transit, my internet connection is slow, that means whatever that I'm sending, it may not be received at the other end. So at that time they are not gonna tell that I have not received it, or they are not gonna tell I need it again. Okay, so that is UDP. Okay, so it is unreliable delivery and no say acknowledgement, no error recovery. So what happened was, say error. Okay, they have missed out certain, say if at all I tell good morning, somebody might not have heard this good morning. Then what happened was, say they have some errors there, they have lost some packets in the transit, or they have lost certain segments in the transit, maybe because of some error. If it is error, TCP tell you to, or TCP tell the source to resend it. Okay, but the UDP will not tell to resend. That is why they have lost the good morning message that I've told. Getting it, guys? Everyone? Okay, so now again let me tell you some applications. So here for TCP you can use, or the application is the HTTP. When you use the normal internet, when you browse the internet and all, say there TCP is used. Now for live interactions, for the live sessions, for the online gaming, for the live interactive videos, for the live interactive audio sessions, then the UDP is used. Clear? So that's the say application of TCP and UDP. Okay, even now also I can show it. So here let me take a packet capturing tool which is called the Wireshark. Okay, the Wireshark. Sorry. So wireless network connection. Okay, you can see lot and so let me stop it. Okay, you can see lot of UDP packets, because now that I'm using what one, I mean the Zoom. Okay, if I stop using Zoom, then all these UDP packets will be stopped. Okay, so you can see lot of UDP. Of course the TCP is also sent, but there is some other protocol, so it is like some other. Okay, so it is something else. So this is the say UDP, which is the Zoom. You can see lot of UDP packets, or the lot of UDP say segments are sent now. Clear, guys? Okay, now let me come here. So these things I've already discussed, you can say check it. Now one more thing I have to discuss: error recovery procedure. Error recovery. So error recovery is done by TCP. I just told you that error recovery is done by TCP. Okay, and now let me tell you what is error recovery. Suppose segment. So can you read it? Can you see at the back? Okay, do you want me to say zoom in again? No,
It's fine.
fine. So now suppose say the computer 1 has sent, so this is the source and this is the destination. Okay, so the source has sent say 3 segments now. Okay, now what happens is that say they will acknowledge back for the 3, then they will again send back another 3. This time the segment 5 has not been reached at the destination, something got lost in the transit. Then I told you, if it was TCP, TCP will ask the source to send it back. So that is the error recovery procedure. So the TCP will send it, say, hey, acknowledge 4. I have got up to 4, but please send 5. Please send 5 because I have not received the 5th segment. I have not received it. Please send 5. So what he will do is that, say, he will send back the 5th segment. Clear? So then he will acknowledge for everyone. So this is the error recovery procedure. Got it, guys? So it is done by the TCP, not by the UDP. If at all UDP didn't receive it, say he didn't receive it. That's it. He has lost it. That's it. Clear? Okay.
Like in TCP, how many times it will? Just one time?
Again, if at all again it has lost, again it will resend it.
It will keep on trying.
Keep on trying that. Okay. Now, so again, in connection termination, you have, say, you can go through this one. Okay. Now UDP, the same thing I have told you, the application of TCP and UDP, that's it. Okay, and the comparison between TCP and UDP. See, that's the same thing that I told you. So UDP, it does not have any connection establishment. Okay, you can read it. TCP uses 3-way handshake, UDP does not. Say it just blast away the data from the sender to the receiver. Then no connection state. UDP does not maintain the connection state. TCP has got a lot of connection states. Okay, active state, then like that they got some connection states. Okay, but say UDP does not have any connection state there. Okay, now, so not on UDP, say the application of UDP and TCP, you can read it later. Okay, now suppose you are using TCP. Where is it? So now that you are using TCP, okay, I told you, say, I suppose that you still remember the diagram, right? So the frame, sorry, not the frame, the segment structure. The segment structure. So in the segment structure, give me a moment. So the segment structure. So the segment structure will be like this. You got the message here, right? Now you got the network layer header. Sorry, not the network layer header, guys. It's the application layer header. Okay. So then the presentation layer header, then the session layer header, then the transport layer header, then the network layer header, then the data link layer header, and the data link layer trailer. Now this structure is the segment. So this structure is the segment. So segment here consists of this one. This is the segment structure. Okay. Now, if at all at the transport layer you use the TCP protocol, then you will have TCP header. Okay. Now, if you use the UDP protocol in the transport layer, you will have the UDP header. Okay. So now let me show it to you here in the capture. If you say, let me double click it, you can see. Okay, this is the data. This is the data, and here you have got, they are using the UDP, then you will have the UDP say header. Okay, and if at all I take the TCP, where is TCP? Okay, so TCP. So TCP here, it uses TCP header. Clear? Now let me just teach you about the TCP headers, TCP and the UDP headers, which is also very important for you. Okay, so now again, can you read it, or do you want me to expand or zoom in at the back? Able to read it? Sure? No? Yes, because usually say almost everyone will say tell me to zoom in. Okay, no worries. So let me just So now let me tell you, this might be much better. Okay, so now, okay, first you got something called, or now give me a moment again. Now is it visible, guys?
Yes.
Okay, now first let me tell you, it consists of a value called port number. It consists of a value called port number, the source port and the destination port. Let me tell you why it is used. Okay, so here suppose we got two computers. We got two computers, and these computers are, say, sending certain messages to each other. Okay, suppose he is sending some HTTP related message. Some HTTP related message. Suppose this is a web server. They are sending certain HTTP related message. Now you can send some other things also. Suppose you can send some FTP related message, or some other SMTP or whatever. Okay, you can send different message. So it is different protocol, right? Say the HTTP, it is different protocol, and FTP, it is different protocol. So here you need, so this machine is receiving, say the web server is receiving the message from, say suppose 10.0.0.1 machine. Then say he knows that 10.0.0.1 machine is sending something to him, but he need to understand this is the HTTP and this is the FTP protocol. So to differentiate the protocols, or to differentiate which message it is, you got some value called port number. You got values called port number. So when I tell you it is port number, do not think that this is certain physical ports. Okay, so ports, when I mean ports, you might think of the physical ports. In the back side of your computer, you might see a USB port, you might see, say, a VGA port, you might see some other ports like that. So these ports are not visible ports. These are just some logical ports. These are some logical ports. You cannot see them. If you ask me like, sir, just show me the port number, just show me it, show me this, I can't show you because it doesn't exist physically. This is a logical concept. This is just a logical concept. So if at all this computer is sending something, some message with the number, the port number 80, with the port number 80, when the web server reads this, when the web server reads this message, and say if he comes to know about this number 80, then he will understand it is an HTTP message. Clear, guys? So this is just a logical number which helps the computer decide, or which helps the computer to understand which message it is. You can't see this number, or you can't see this port. Okay, now if it is, say, FTP, it might be, the number might be 20 or 21. Okay, suppose it is 21. Okay, then they will understand it is FTP, it is FTP related message. Clear? So that is the port number. So when they send it, when they send these segments, they will have the source port number and also the destination port number. Okay, so the source port number can be any random value. The port number is actually a 16-bit value, and the values can change from 0 to 65,535. It's just a number whose value can range from 0 to 65,535. Clear, guys? So this source port number can be a random port number, whereas the destination port number, suppose this is a server, then it can be a specific number, 80, 20, 21, or if it is DHCP, then it can be 67 and all. It can be 67, 68 and all. Clear? Okay. Getting it? Okay. Now, so where is it? Yes. So that is the source port number and the destination port number. Then I told you, you got a sequence number. Right, sequence number, I told you, whenever you send something, they will have, whenever you send, say, some segments, they will have the sequence number. So the sequence number will be, say, suppose 1000, 2000, they will have the, they'll include the sequence number in this field. Got it? Lekshan?
Yes, sir.
Okay. Lekshit?
Yes.
Yes. Okay. Now, acknowledgement number. Okay, so acknowledgement number means they are sending back the acknowledgement. Boring? No? Okay. Now, so some faces. Okay. Almost done, guys. Okay. Yes, almost is 9:54. So I'll say complete this one and we'll wind it up. Okay. So now acknowledgement number. Acknowledgement number means you can identify that. So I told you whenever you are sending the acknowledgement, they will fill this acknowledgement number. Acknowledgement number 4001 or acknowledgement number 5001, like that. Now you have another value called data offset. Data offset means it specifies the size of the header. It specifies the size of the header. The header size can be from 20 to 24 bytes. It can be from 20 to 24 bytes. Okay, now then you got one field called reserved field. It's called reserved. Reserved means it is reserved for some future purpose. Reserved for some future. It has not been assigned yet. It is reserved for some future purpose. Clear? Okay. Now, so now you got some bit values. These are certain bit values. So let me draw it. Okay. Okay. So the first bit is called congestion window reduced. Congestion window reduced. And the second bit is called echo congestion. Okay. Both are used for congestion management. Both are used for congestion management. I might have told you that, say TCP will have the congestion management. Congestion means suppose if I am sending something, right? If at all I am sending something and they got lot of traffic, then that is called congestion, right? Say if at all you are in a line, so suppose that say you went to buy something. Okay, you went to buy something and there's a long queue and lot of people, then you will feel congested, right? Say that means say a lot of people are there. So again the same thing here, say congestion here means lot of traffic. Okay, so now so it is used for the congestion management, these two bits. Now U means urgent bit. U means urgent bit. Urgent bit means if at all you have any urgent values to be sent from the say source to the destination, this bit will be set. The urgent bit will be set. Okay, now A means if it is acknowledgement or not. If it is acknowledgement, then this bit will be set and the acknowledgement number will be filled. Clear? Now P here means push the data. Push the data. Push the data means in case of insufficient data. Suppose, let me tell you an example. Suppose that say suppose you want to travel from Bangalore to Delhi. You want to travel from Bangalore to Delhi and you have say booked the tickets for a flight. Okay, now so now suppose when you went to the airport, say they cancel the flight. They cancel the flight because say you are the only person to travel in that flight, suppose. So that means you do not have that much sufficient say people there, so they have cancelled the flight. What will you do? So this is say you will push it. Suppose you are an IAS officer or you are an IPS officer or you are some say like bureaucrat or some say what do you say, the rich person. Okay, then what happens is that you can push them. No, say I will raise a complaint against you, so I have to get here by that time. You have promised me the tickets and you have to get me like that. And suppose so you can push them and say if you do not have the insufficient amount of passengers, or then you can push them, right? The same thing here. If you do not have the sufficient say data from the source to destination, sometimes you will not have that much data. Okay, but still say you may have some values that needed to be sent from the source to the destination. At that time, if the push this field is set, then they will be sending the data. Clear? Even if it is insufficient amount of data. Clear? Now then the second value is called reset, or not the second value. So this value is called reset. If you want to reset the connection between the source and the destination, you will put this value. Okay, or you will set this value called reset value. Now this one is called, you already know this is the SYN bit. This is the SYN bit, which is used for connection establishment. I told you in the connection establishment they'll set a SYN bit. This is the SYN bit that they'll set for the connection establishment. And you got the FIN bit. For FIN bit they will use it for connection termination. Clear? Okay, now again, okay, alarm. Okay, so suppose in some classes I'll hear alarm. Okay, that means it's time to end the class. Okay, yes guys, just let me finish it. Okay, within just 2-3 minutes. So here the next one is called window size. Okay, so window size here, it tells you the window size. That means how many how many segments you need to send from the source to the destination. I told you they will update the window and all, right? So that is the window size. Okay, then checksum. Checksum means a simple error checking mechanism. Okay, now urgent pointer. So if this urgent bit is set, then this will point out to the urgent pointer, which says what are the data which is urgent. It points to the urgent data in the values or in the data. Clear? Okay, and at last you got some options field. These are optional values. Clear guys? So this is the TCP header. Okay, I thought to show you the header values. So here you got a TCP. So if you capture this, you can see the transmission control protocol, you can see the source port number, destination port number, then the sequence number. So the sequence, this is the sequence number, the real sequence number. This is a very great value, very higher value. Okay, sequence number, raw sequence number, then say the header length. Okay, 20 bytes. I told you the header length is 20 to 24 bytes. So this header, TCP header, it consists of 20 bytes in size. And you can see the flags. Flags, only acknowledgement is set. Okay, you can see only acknowledgement is set here. Okay, so here you can see many things here. So you got, says, yeah, one more thing it has come, no nonce or something, I really don't know that. Okay, so this one, congestion window reduce, echo congestion, then urgent, say acknowledgement, push, reset, SYN, FIN, and this acknowledgement bit is set. That means this is the acknowledgement that my computer has received back. Okay, then again showing you this one. Okay, the window size value, it is 16. Okay, now the checksum value, the urgent pointer, and say the timestamps, the optional values. It consists of many values including timestamps. Okay, so these are the TCP header values.
Will it show the protocol also, like HTTP or?
Of course it will show. So here now let me take HTTP header. So here this is the TCP. Okay, so this is the TCP. You can see, say, okay, let me just take some other, yes, this one, TLS. Okay, this is the another one. This is not the HTTP. TLS is another protocol, transport layer security protocol, which is for security. Let me take another one, HTTP. This is TCP. It might have the data, I suppose. Okay, yes, no, not in this one. Okay, so it will have, say, if you are browsing, say now, okay, let me just capture it one more time. And show it to you. Suppose facebook.com or whatever. Okay, Flipkart. Suppose taken Flipkart. Okay, I suppose this will not be there, 80 will not be there because it's, yes, this might have it, I suppose. Nope. TCP, this one, retransmission, duplicate application like TLS only, encrypted ones. Okay, these are encrypted ones, guys. Okay, unfortunately can't show it to you now, so you can say here, say suppose if you are using the HTTP service and all, later you can see this one, the application layer. Okay, so this one, say after this, say the TCP, so this is the TCP header. Okay, this is the network layer header, which is the IP header, which you will study tomorrow. Okay, then this is the layer 2 header. Okay, it consists of, so the layer 2, it consists of the MAC addresses and all, which you will study tomorrow. Okay, tomorrow let me take it and tomorrow I can show it to you. Okay, yes. So then shall we wind up the class for today? Okay guys, yes. So thank you, we'll get back tomorrow then. Okay, and by the way, just hold on a minute guys. Okay, so let me stop recording.